So hello everyone, my name is Gabriel Brown. I'm Principal Analyst with Heavy Reading, where I lead our mobile network and 5G research service. Joined today by Vikram Prasad, Director of RAN Services at Amdocs. He's our expert guest speaker. Welcome Vikram, great to have you with us.
Hey Gabriel, thanks for having me on.
Yeah, let's kick off. Maybe you could just explain a bit about your role there at Amdocs and what you do.
Yes, thanks, Gabriel. My name is Vikram Prasad, and I actually work within the Open Network division for Amdocs. I'm actually responsible for global mobile services and solutions related to different technology rollouts, and specifically now, given the fact that we have 5G, across the country, across the globe, I'm actually leading the 5G mobile services for the division, also looking into current deployments that we have, as well as how we can actually shape our future strategy around 5G services. Our division, which is the Amdocs Open Network, we actually work on services and solutions covering the OSS, NFV, policy, and mobile. We have a very innovative portfolio around these offerings that actually help the service providers realize the vision of open cloud networks, where the future of networks will actually be programmable, elastic, efficient, and automated.
Okay, and when we look down then into the, I guess, RAN division or RAN services we're talking about, I'm guessing a lot of that is around 5G right now, given we have operators deploying on all continents. Well, just scope out a little bit that product offer you have.
We are a software services company, and automation is part of our DNA. So in terms of like 5G deployment and rollout, we have actually providing solutions that actually automate the recommendations and insight right from planning, spectrum usage, that can be used for densification and deployment of small cells and macros in different spectrum bands. We also have automation in our deployment phase, where we have actually accelerated the commissioning, integration, and acceptance, and have launched over 50,000 sites, not the 5G sites, 5G sites included, but predominantly on the LTE and LTE side of the house for Tier 1 service providers globally, enabling them with a faster time to launch with very good quality.
I was just going to say, I get that you have the you do planning, design, optimization, and so on. Are you involved in the actual, as it were, installation and commissioning?
Yes, we do the installation and commissioning and integration of the 5G sites also, and that's where we have an innovative portfolio of a faster rollout portfolio, where we actually have automated tools to have the field technicians on the site actually turn up sites faster, troubleshoot the sites faster, and get the acceptance of the 5G sites much faster. We have actually had efficiencies of about 25% with faster turn up of the 5G sites, which actually lead to faster time to market for the service providers.
Yeah, good one. I'm glad to hear you have these tools for the installation crews. I was actually on a site visit here in London, a 5G site visit earlier today. One of the key things the installers were telling me is they need these. They have an app which kind of basically allows them to complete all the paperwork to install and commission the site. Saves them 2 or 3 hours when they get home every day. So they were delighted by it. These are independent contractors, I guess. A little like yourselves, but the other thing they said is, if you can commission and accept a site sooner, the vendor can bill for it sooner, the operator can get on with paying for it and rolling out service. So those tools are really key. I mean, if you think we're talking about tens of thousands of sites right across pretty much any country these days.
Absolutely, Gabriel. I mean, if we have to actually reach the densification targets for 5G, I mean, the rollouts need to be really fast. And, talking about our division over here, I mean, we have actually built these proprietary applications where we actually deploy it on the field. It's basically the same as what you were actually mentioning, mobile apps that actually, track the progress of installation, commissioning, has like automated scripts and also automated troubleshooting which not only provides a faster turnaround time, but also reduces the time the NOC actually spends troubleshooting. We have innovative apps around not just the installation, commissioning, integration, but also the acceptance. The app also has the functionality to do a quick handoff drive test and give real-time metrics as to how the site's performance is, so that they can actually be easily accepted. We have those innovative solutions that we have actually built for the service providers to accelerate their 5G rollout.
Yeah, and given your kind of role in the ecosystem here, as we're going to 5G, I guess, do you see obviously lots of different operators and work with them, and obviously each one is kind of confidential and so forth. But I was curious, do you see sort of operators tend to be similar in their planning and deployment strategy, or do you see big differences between them?
The first thing is, the spectrum of choice, for the initial testing and deployment for the service providers have actually been one, where the bandwidth has been large enough for them to actually demonstrate the capabilities of 5G. Currently, what we are actually seeing is operators are taking different approaches to their 5G deployment strategies, although their transition is still to a non-standalone option 3x. So that is a common transition for all the operators. But then within these deployments itself, the way they're actually deploying it on different spectrums are actually the differentiator. So if I just talk about North America, we see like Verizon and AT&T, for example, deploying many small cells on their millimeter wave spectrum, where they have like a massive amount of bandwidth, which give them more than a gigabit of speeds that are actually helping them provide enterprise fixed wireless access. For example, that's their primary target, and then they are actually following a similar strategy of not only on their millimeter wave bands, but also on their mid band and low band spectrums. I mean, there's an auction next year for the mid band spectrum, which is actually going to have the operators gain more spectrum out of it for 5G deployment. But then when you actually look at Sprint has a different strategy where they're actually deploying it on their mid-band 2.5, and they have they have a good chunk of spectrum bandwidth on the 2.5 spectrum. So they have good coverage, as well as they are actually having good speeds. So they are able to actually have the good speeds, as well as they're able to target mobility and get the coverage for the population that they are actually deploying. T-Mobile, on the other hand, is actually deploying millimeter wave cells on dense pocket areas, and then they have their 600 megahertz rollout on low band spectrum. So, but then going with the merged entity, once it actually is all settled, they are going to have their 2.5 from Sprint, which makes them actually have a 5G strategy on covering all bands, all their bands.
Yeah, I get that. I mean, I think I've used a few of the commercial networks here in the UK now. There's two really properly live and commercial. The Vodafone and EE. We have a couple more coming in the next couple of months. I think they're both 3.5 non-standalone, are probably closest to what Sprint's done, I guess, versus the millimeter wave deployments that you have. Given that you are, I guess, pretty much neutral in terms of RAN vendor, you work with all of them. How much variation do you see there? We talked about the operator side, but do you see significant differences between Ericsson, Nokia, Samsung, that type of thing, or are they much for muchness? How much does that influence how you design and build?
That's a good question, Gabriel. So first of all, I mean, we are a services integrator, so we are actually vendor agnostic. So we actually have experience with all the vendors that you had actually mentioned, Ericsson, Samsung, and Nokia. But what we are actually seeing with the current deployments is that vendors are actually prioritizing certain features and rollouts depending on the operator's needs and requirements. So you have a roadmap where the operators are actually based on the spectrum, the band that they actually have, they have certain needs and priorities, and based on those, we are actually seeing the vendors actually roll out certain specific feature sets. Some OEMs, for example, support the enhanced dual connectivity mode, for example, and some of them actually don't support them as of yet. They have it in their roadmap, which they'll actually, they can deploy it or they can get those features later. The ENDC mode, for example, allows the 5G device to actually camp on both the LTE as well as the NR leg. Some of the OEMs support, NR over uplink, a multi-user MIMO, whereas, some of them actually don't support those features. So the scheduling algorithms between NR, LTE legs, we still see that there are differences between how operators, OEMs actually calculate those. So we are seeing, features around how scheduling is actually done, being fine-tuned over, the next couple of releases. But then, we still have a lot of good other features that's probably going to be coming up by next year, which is actually going to enhance the current offering of 5G, which is some of them like uplink, NR, plus carrier aggregation on LTE, which probably is going to boost the current LTE, current uplink throughputs, and of course also the 1024 QAM modulation schemes. Along with this, we also have the big one, which is the dynamic spectrum sharing, which is actually going to have 4G and 5G spectrum sharing within the same band. So that's going to be huge also for service providers to actually make use of DSS for providing more coverage on capacity on their 5G networks.
Yeah, I was speaking to actually quite a lot of the different operators and actually vendors as well. They seem to be sort of, I can sort of characterize it in general. I think everybody's in not quite the same place, but everyone's pretty much on, I guess what I call sort of, it's commercial equipment now, but it's first gen. There's there's quite a few bits and pieces still to work out. All those different features you mentioned, how you'll kind of upgrade and scale into release 16, release 17 features, that sort of thing.
Absolutely.
Yeah, it's going to be really interesting to see. I mean, what we obviously hope for is that the RAN that gets deployed today is good for 5 years or so, rather than has to be swapped on these new features. What you mentioned there, some of the the sort of migration to or the NR on low band. What's the how much variation there do you see in strategies? Because obviously there's dynamic spectrum sharing is one. There's some people talking about, not so much in North America, but here in Europe, maybe having a clean NR band for 700 or something like that. Others are talking about maybe you need to, you talk about LTE aggregation on the uplink, I think, but maybe you need to do NR aggregation on downlink in some situations. How much in flux is all of that? Do you feel like you have a clear map forward, or you're still kind of figuring it out?
Like in dense urban areas, for example, you have your NR. You can deploy your 5G on your option 3X. You can actually deploy as much as you want to. Especially, but if you're actually going out of 5G, especially in less coverage areas, you would actually want to use dynamic spectrum sharing, for example, which gives you the benefit of having 4G as well as 5G work in times. Not always. You can also serve the existing LTE traffic, but then when there is that 5G user traveling over there, based on their traffic aware situation that DSS actually comes with, it can actually switch over and actually give that much needed 5G service to that person over there. So we can actually look at deployments where, given the fact that you have dense areas, you can actually go ahead and deploy your, option 3x and then move on to a standalone kind of a network. But then when you're actually in going away from dense areas, you can actually just, be on your 4G network and just switch on the DSS and have, the users actually camp on both 4G and 5G in different scenarios.
Yeah. Where are you at on, the standalone migration strategy? Obviously, it's not being deployed yet. There's quite a few moving parts to that. Are you, what's your thinking there? I guess I'm wondering out loud, really. If I think back to LTE, a lot of operators deployed LTE for broadband, worked pretty well. Then they introduced VoLTE, and they had to kind of replan the network, re-optimize. Are we likely to see the same kind of thing with SA? When we want to have NR control plane, is that going to need a kind of wholesale re-optimization? Do you think, or are we kind of good as we are with the LTE base?
No, I mean, if we are just talking about, like, just say option 3x. With option 3x itself, what we are actually seeing is, just on let's say, for example, on the planning side, irrespective of whether it is option 3x or standalone, on the planning side itself, if we are actually going to deploy and densify in very dense urban areas, there's going to be a very tight planning that's actually needed because of the inherent limitation of the PCI and the RSI, the rad sequence index, on the number of codes that can actually be used, shared for the small cell planning to actually get to densification. We also see that, use of 3D maps actually become essential, especially when, we are using massive MIMO beamforming technologies to identify where to actually design the antenna needs for fixed wireless use cases. C-RAN and D-RAN deployments actually become more critical. So the fiber lengths actually need to be evaluated. Backhaul upgrades need to actually be done. So on the planning side, we actually are seeing, not a lot of challenges right now, but once we actually go into the densification mode, definitely, especially given the fact with millimeter wave propagation, we definitely would see a lot of challenges on that side. On the optimization side, at least for the option 3x, what we are actually seeing right now is, we are seeing typical issues on, like thermal issues. We are actually seeing overheating of the devices, which is actually, causing the NR legs to actually break, which leads to a, significant loss in throughput. We actually are seeing, beam acquisition failures where, the devices actually lose sync with the massive MIMO beams. We have, issues with like NR leg dragging because the LT, it's not consistent in measurement with the LT leg. And we have like SCG configuration failures due to sync issues. So when I actually look at issues that are there right now with option 3x, and once we actually go to a standalone mode, which actually gives us, which brings with it the 5G core, that's a whole new element of, interoperability that we'll have to actually have with, the 5GC, with the EPC, especially in areas where it's actually handing down to LTE. So they're like, when VoLTE was actually introduced, VoLTE had that, the end-to-end kind of issues. Like it was not just RAN-specific issues, but it was also core-specific issues on the IMS side of the house. So my take is that, when we actually go to standalone, we will still have to go through those interoperability issues, especially given the fact that, where we have standalone cells and where we have like, LTE cells, those are definitely areas where a lot of optimization, fine tuning needs to actually be made to have the user seamlessly transition between the two technologies.
Yeah. Plenty to work on there then. You mentioned a moment ago DRAN and CRAN. Are you seeing much change in, I guess, what we could think of as, broadly speaking, as in RAN architecture? I get the impression the US operators are perhaps being a little bit more adventurous or ambitious in that regard than the Europeans, who typically it's DRAN in Europe and Korea and so forth. Is that, are you seeing any adoption of new architectures there? I think the mmWave obviously plays in that a bit with mobility management and things.
So we are seeing pockets of North American operators actually deploying vRAN. So definitely that is actually happening currently in North America, and not just North America. I mean, we have actually been working with certain RFPs outside of North America, also in APAC and specifically around APAC, where they are actually either going for a greenfield, complete greenfield standalone solution, virtualized solution, or they are actually going through like a hybrid kind of solution. So definitely vRAN is something that is in the horizon, and especially given the fact that we have to actually go to standalone 5GC to actually achieve those ultra low latency use cases. We have to have a virtualized network, or at least a hybrid network, that actually gives that flexibility to scale when the capacity is actually needed. So right now we do see that the architecture is still 3x NSA, but we see an introduction of vRAN slowly, which brings the virtualization along with the centralized or the distributed RAN, which then goes into an option to standalone. So that is how we're actually seeing.
Yeah, got you. Pockets then, another area where we're seeing, I think it'd be fair to say, characterized as pockets of progress, and it's kind of super fashionable right now, is private networks. Deployed on a campus or an industrial facility or these types of things. What are you involved in that? On
the private network side, yes. So we are actually an FCC approved SaaS administrator. So we actually have our offerings called Spectrum One. We got a conditional license, which is now a full approved license to actually be a SaaS administrator. And with our Spectrum One offering, we actually have remote access to a hosted SaaS service. We can actually, right now in North America, CBRS 3.5 is a hot topic, and we actually have registered CBRS devices, CBSDs, which we have actually tested and gotten approval from FCC to actually start providing 3.5 services to the enterprise customers or service providers.
Yeah, I must say I was not aware you were a SaaS admin, certified and everything. That's interesting to know. Are you also I suppose one of the observations around private networks, everyone will say, well, look, if you're an industrial company or whatever type of company you are, you're maybe not expert in mobile network design and optimization. Is that a sort of an area where you're active or pursuing? Is it in terms of basically helping the private network operator actually design the network they need for their applications?
It's not only design the applications, but we have a big partner ecosystem, Gabriel. So we have partner ecosystem where we can actually bring in not only the design and planning, but we can actually partner with our existing partners to actually provide the entire ecosystem of the RAN environment as well as the core, the backhaul. So not just planning and design, but also helping them deploy with partner vendor equipments that would actually help them, get their private networks up and running.
Okay, yeah, I see. So basically putting together a solution, as it were.
Yes, absolutely.
Yeah, very interesting. Thanks very much, Vikram. I think we hit on, probably a dozen sort of really hot topics there. Would be great another time to go into a couple of them in more depth. But yeah, thanks very much. That was very interesting.
Hey, thanks a lot for having me on, Gabriel. It's been a pleasure to talk to you.
Terrific. Thanks. Look forward to having you back another time.